trying to think how this is going to work best. This is the chapter where it feels real. No, it does. It feels like you're doing real chemistry now. And part of that is you will sound much more intelligent by the end of this chapter than you have up to now. Not that you're all not very bright people. But up to now, when we do a lab, you look at a flask and you go, it's got KCl in it. After this chapter, you'll go, oh, it's potassium chloride solution. You know, you will no longer look at the MgCl2 and go, it's MgCl2. You'll say, oh, it's magnesium chloride. So you sound more like chemical-speaking adults after this chapter than you did before. Chemistry is a whole language unto itself. And so now we're really working with the language of chemistry. And there's a lot, it's interesting because it's a blend of language and math, and you're going to apply all of that. So at the end of this chapter, you'll be able to name any ionic compound I hand you, name any molecular compound I hand you, and write formulas for any ionic or molecular compound that I hand you. So you really develop a whole skill set here that allows you to do real chemistry. That said, let's start off with some of the basics. What is a chemical formula? So there are two different big breakdowns in terms of chemical formulas. And for molecular compounds, they actually show the individual atoms that are in a molecule. So glucose is the one we use again and again and again and again because everybody loves sugar. C6H12O6 actually has 6 carbon, 12 hydrogen, and 6 oxygen in it. And that's a discrete, independent unit. It is a glucose molecule. Those have a whole set of naming conventions, and we actually do those second. What we're going to start off with are what are maybe slightly trickier, the ionic compounds. So ionic compounds don't have molecules. We talked about this when we talked about the characteristics of ionic compounds. There's no individual unit that is 1 sodium and 1 chloride. There are just ratios. So it's called a formula unit rather than a molecular formula, and it's just the ratio. So for potassium bromide, KBr, that's a 1-to-1 ratio. For calcium bromide, CaBr2, there is 1 calcium for every 2 bromide ions. Okay. You'll notice that on KBr, are there any visible subscripts? No. When the subscript is a 1, we don't show it. So we never show a 1 as a subscript. Okay. So for the ionic compounds, you're just looking at the charges balancing, and we're going to do a lot more work with that. Okay, we're going to start off talking about monatomic ions. So monatomic, mono means 1. So these are ions that are made up of only 1 atom. This is a single atom that has gained or lost electrons. And we talk about the main group. When we talk about the main group, which blocks are we talking about on the periodic table? S and P blocks. So this is group 1 and 2, and then 13 through 18. And they all tend to be attempting to look like a noble gas. So I'm going to give you the next periodic table you're getting from me. On the back side of this document, and this document I tend to refer to as the Ion Bible, because you will live and die by this thing. And it's got pretty much everything you need to use for the rest of your chemistry experience. It's got a lot of information on the back. This is compiled from a couple of different sources, your textbook, a college chem textbook, some other stuff. But the first box at the top that I'll direct your attention to is just a reminder, because you already know that if something is group 1, it wants to give up 1 electron to look like a noble gas. So group 1, when it gives up 1 electron, tends to have a 1+ charge. And that top box reminds you, oh yeah, group 1 plus 1 ions. Group 2 tends to give up 2 plus 2 ions. 16 tends to gain 2, 17 tends to gain 1. And then we have these two, aluminum and nitrogen. And they're noted here. And they tend to form ions with a 3 charge. Aluminum tends to form a 3 plus. Nitrogen tends to form a 3 minus. So those are right there on your paper as nice handy reminders. You won't use that part of the graph much. When I said that by the end of this year I would be able to wake you up at 2 in the morning and say, quick, what ion does calcium form? And you'd go, +2, before you even asked me why I was shaking you awake. This is where that happens. This is the chapter where you get that good with it if you're not already. So this top part you'll hardly ever use because you pretty much already know that and you're going to be totally fluent in it by the end of the week. This next box down relates to the group D elements. So the D block, if you remember, have some weird stuff going on with their electrons. Their electrons are not affixed to a particular nucleus. What do we call that sort of model of metallic bonding? It's the come with me to the sea. Sea of electrons? Electron sea? Yeah? They're delocalized is the big thing. So they're all sort of swimming around in this big pool of electrons. What it means is that D block doesn't necessarily have a specific ion that it forms. And in fact, a lot of those D block elements will form more than one ion. Oy. We have some that are +1. They're all positive. That's one important thing. They are always giving up electrons. They are never taking them on. The D block always form cations. That said, they can form +1, +2, +3, +4. There are a few things that form +5 and +6. Those are less common. And not everything will form every ion. Okay? If you look on this chart, what you have here are the most common. Now, because it's not on the chart doesn't mean it doesn't exist, but these are the most common. So, forming +1s. Copper forms a +1. Silver almost always forms +1. Silver doesn't really form anything else. Chromium forms a +1. Now, you might notice chromium also forms a +2, a +3, and I think I left off, there is a chromium +4. There's also a chromium 6 ion. Forms all kinds of crazy ions. So using this chart is helpful in remembering which commonly form certain ions. Okay, so when we name monatomic ions, the cations are the easiest. So the cations are dead simple. These are positive ions, and they just get named for the element plus the word ion. So sodium 1+ is a sodium ion. Calcium 2+ is a calcium ion. What is this called? What's that called? Yeah. Or aluminium, as the Brits say. Yeah, aluminum ion. Okay. Easy. If I give you anything with a positive charge, it's just the name of the element plus the word ion. Cool. We can do this. This is good. Do you sense that it's going to get worse? I think there's a lack of trust. I think you think that every time I say, okay, cool, that's easy. But that's pretty much the way it works, isn't it? Okay. So let's talk a little bit now about anions. So anions have a negative charge. And when we are talking about monoatomic anions, we have an ending change. So chlorine, the element chlorine, gives up or gains an electron, gives us a Cl1-, and that's no longer called chlorine. That is now a chloride ion. It gets an IDE ending. Okay? That IDE is incredibly important because what's going to happen by the end of this week or early next week is you will have IDEs, ITEs, and ATEs, and they will all mean different things, and you will keep them straight. Oh boy. Now, the good news is they're all on here, they're all on your Ion Bible, and the even better news is you will use this on your homework, on your quizzes, on your tests, on everything. You will always use this. And you will get so familiar with this. The first year I taught chemistry, I went back to what my high school chemistry teacher had done. I was going to make them memorize their polyatomic ions. They were going to have to take a polyatomic ion quiz. Yep, they're all going to memorize them. Stupidest thing I ever did. One of my worst teaching decisions ever. It was dumb. No chemist sets out to memorize their polyatomic ions. Do you know how you memorize your polyatomic ions? You look them up 4 billion times in the course of practicing writing names. So you use this. You use this on your homework. You use it on your quizzes. You use it on your tests. By the end of this year, I can guarantee that you will all have memorized the 10 or 15 that you use most commonly. You will not have attempted to memorize them. It will just have happened because after you look up the nitrite ion and the carbonate ion 463 times, you don't have to look it up anymore. So it's going to happen. We're going to rewrite your brain without your permission. Ha ha! But this IDE is super important. If you see an IDE, we are talking about a monatomic anion. Okay, that's really important to remember. IDE means it's a monatomic anion. So let's practice a few of those, shall we? So these are our monatomic anions. What would this be called? Okay, jot it down. Don't say it. Jot it down and then compare notes. This is the bromide ion. Okay. So let's do another one. Let's do one that everybody hates. Oh geez. Wow, none of you caught my screw up. Anybody catch my screw up and think, well, that's weird, but she must know what she's doing?
Is it bromide?
No.
Bromine.
No, it's bromide ion.
Oh, you didn't.
Whoops. That was dumb. Okay. So, and that is recorded. So, N3 minus. What would that be called? Write it down. And then compare notes. So we have the nitrite ion, O2 minus. What would that be? Okay, that is the oxide ion. Here's the one that everybody hates to pronounce. Name it. Jot it down. The iodide ion. Okay, so not so bad. Remember when you see the IDE, we're talking about a monatomic anion. Negative and single. That's important. We can name positive and negative monoatomic ions. Only one kind left to do. So this is the D block. These are the weird ones. Same slide, but here's what we got to talk about. Because these D block elements form multiple ions, we always have to specify the charge. So Cu1 plus isn't, you can't just say that's a copper ion. It's a copper 1 ion. Okay? And the charge is always designated by a Roman numeral. It's always in parentheses. And remember, these things are always positive. So, well, let's do chromium, because that's one of the ones that forms multiple compounds, or multiple ions. So Cr4 plus is what? Jot it down. Okay, so that's the chromium 4 ion. Well, let's do one of these backwards. So if I told you that I had a nickel 3 ion, write it. Ni3 plus. So, this is one of those Grant's tomb kind of questions. Do you know who's buried in Grant's tomb? Grant. So, when I say to you, what's the charge on a copper 2 ion? 2. Don't you dare tell me the charge on a copper. Let's do a little bit more practice. Oh, and I should mention the quiz structure for this. Yeah, let me do that first. Let me mention the quiz structure for this. So today we are working on monatomic ions, binary ionic compounds. By the time you leave today, you can name me any monatomic ion. You can name me any binary ionic compound, which is what we're about to do, and you can go in reverse. If I give you the formula, you can tell me the name. You'll practice that today, and you will have an online FIP quiz tomorrow. This is something I haven't done much with you guys because the chemistry doesn't quite lend itself to that the same way. I do it a lot with biology. So you'll have 3 FIP quizzes, one tomorrow, starting tomorrow, online, multiple choice, for each new naming and writing formulas skill that we practice. Once you've gotten those 3, and on each individual piece you've said, okay, yes, I have this, no, I'm a little weak here, I've got this. Then we roll all of it into one big ball, and you begin the fun, which is your naming quizzes. And the naming quiz will combine all of the naming stuff that we're doing. It's typically 15 questions. You must take it until you get a 13 out of 15. Each time you take it, the score that you can receive is 1 point lower. So if you get a perfect score the second time you took it, what will show up in the book is second attempt, 15 out of 15 in the notes, and then your score would be 14 out of 15. I've never had anybody have to take it more than 4 times. So, and there's a real incentive to get it on the first or second try because you get your most points that way. So you'll have plenty of FIPs to do before then, and the FIPs will, being online, the FIPs will be open. You can go back and practice them on your own without even having to ask for a copy. You just go back and link to them. So, now that we know how to name ions, we want to start talking about binary ionic compounds. Bi means how many? 2! Yep. So binary ionic compounds are made up of 2 different elements. And obviously, they're ions. 2 different ions. How many of you have ever been on a teeter-totter? If you haven't, you have homework tonight. Go find an elementary school playground in the snow. I don't care. It's homework, and I take it seriously. Wear your snow pants. So in an ionic compound, the charges have to balance. So if you have 1 positive charge, you have to have 1 negative charge. If you have 2 positive charges, you have to have 2 negatives. You get the picture. Now, what's true is that, well, it's very easy if you have something like this. You have sodium, which is 1 plus. You have a chloride ion, which is 1 minus. 1 sodium cancels out 1 chlorine. So on our little teeter-totter, Na1 plus, Cl1 minus. Well, what if we have magnesium, which is 2 plus, and chlorine, which is 1 minus? Oops. So magnesium 2 plus is going to require 2 chlorine 1 minuses in order to balance the charges. Because remember, ionic compounds are neutral. These are neutral overall, so those charges have to be balanced. How many of you remember the term crisscross method? You said a few of you remember that? Okay, good. Good, because that's what we're going to do. So when we're given 2 substances which are forming a compound, binary ionic compound, get rid of that. The first thing, what we're typically told is, so let's practice one here. I have a substance that is made up of potassium ions and oxide ions. How do I write a formula for that? We'll actually go to the next page because I want to make sure we have plenty of space. So I'm told I have a compound made of those things. Very first thing you want to do is write the ions. So what's the potassium ion? Jot it down. I picked on the whole first row, I'll pick on the whole back row, and then I'll finish up with the middle. Okay, Jake.
K plus 1.
Yep, K1 plus. And what's an oxide ion? Claire.
minus
2 minus, yeah. O, 2 minus. Okay. Now we do the crisscross thing. So we're going to rewrite just the symbols with a space for a subscript. And then we're going to take just the number, not the sign, from these, and we're going to crisscross them. So the 2 goes here, the 1 goes there. Now, we don't show ones. If there's a 1, we just leave it blank. So the third step would be to simplify this. And we have K2O. That's potassium oxide. So the compound is just named for the ions. So this is potassium oxide. Okay, let's practice a few more. I'll give you a name, you write me a compound. Lithium fluoride. Fluoride? Okay. Okay, so you've got Li1 plus, F1 minus. Sam, next step, what you got? Okay. And for cleanup, for our last step, what you got, Raven?
LIF.
Just LIF, yeah. The ones disappear. So that's lithium fluoride. Okay, let's do one more together. Many of you have, well, I bet most people don't have old aluminum screen doors anymore, huh? Anybody still got an old aluminum screen door? They get the little white pits on them. Okay. You know what those little white pits are? Aluminum oxide. If you want to do a neat little science experiment and your parents will permit this, go to the thrift store, buy an old aluminum cooking pot, and go leave it out in the yard for a couple years. Just tell the neighbors it's a science experiment. They won't care. And it will develop little white pits. In some cases, it'll actually eat all the way through the metal. It's basically the aluminum version of rust. It's aluminum oxide. Aluminum oxide is white. Rust is, well, rust colored. Okay, go. Tons.
So Li1 negative?
Aluminum oxide. Okay, so we've got Al3 plus, O2 minus. Second step, Ella, what you got?
Al2, O3.
Al2O3. Yep. Okay. And Madison, last one. Can it be simplified? Nope, that's it. So it's Al2O3. And for some reason, I love the ones that are 2 3s. They're just cool looking. But that's aluminum oxide. That's rust. Okay, let's practice going the other direction real quickly, and then I'm going to cut you loose to practice on your own. Okay. When you go to name, all you have to do is name the ion. Now, in the case of all of these things only form one ion. So, Ca, calcium, forms what ion? What's it named? What's it called? It's the calcium ion. And sulfur is sulfide. So this is calcium sulfide. That's the compound name. So the only thing you really all you have to do is you can drop the ion ending. So you name the ion, but you don't have to say ion because now they're part of a compound. And you just have to remember that the anion gets that IDE ending. So the next one would be, and we're back to start. Mr. Tomlinson, you got it? Okay, let's name the first side. Easy breezy. Really, really simple. Tomorrow, when you walk, so I'm going to give you ample opportunities to practice, which means lots of homework, lots of practice problems. I put the first part of the review assignment up there. In addition, I believe it is page 207, practice problems 1 and 2 at the bottom of the page. I would recommend. The answers are right there. Just do them and see if you're getting them right. Those aren't going to be graded. That's just a recommendation for you to practice. When you walk in tomorrow, you will have an online FIP quiz. And then you'll have instant grades back on that. And then we'll move on to the next kind of naming. We'll move on to stock system. Okay? Get to work.